You know, people always say, get your protein through peanuts or meat. You know, I've always wondered to myself, what is a protein? How would I isolate that protein by size or electrical charge? Well, today, kids, I'm going to teach you exactly how to do that.
Chief Keef, the Science Geek.
Keep going.
Chief Keef, the Science Geek.
One common technique that we use to separate proteins is two-dimensional gel electrophoresis. And
What's that, Chief Keith?
the way this works is there's two separate parts to it. The first part is separation by charge of two proteins. So say we have a negatively charged protein and a positively charged protein. Well, we want to separate them on a column. So we separate them, and once those are separated, we then separate the proteins by size. We run them on the column, separating by size. We can now know what each protein is based on their charge and size. Isoelectric focusing entails a separation of proteins based on their isoelectric values. You begin with a column with an established pH gradient that allows you to measure the varying pI values of your solution of proteins. At the top of the column, an ampholyte solution is added, ampholyte being a solution containing both positive and negative molecules, and an electric field is ran from negative to positive through the column to establish a pH gradient. Once this is done, you add the proteins that you wish to separate by charge, then run a second electric current from negative to positive through the column. Finally, you stain the proteins, and voila! You can now visibly distinguish each of your proteins with either isoelectric or zwitterionic forms.
Well, that was really something. Now that I've talked about the first part of two-dimensional gel electrophoresis, involving separation by charge and pI, now I'm going to talk about the second part, which is separation by protein size.
We begin by coating the gel that we just made with sodium dodecyl sulfate. The hydrophobic parts of SCS attach to the hydrophobic regions of the proteins, causing them to unfold. SCS is also negatively charged, so all the proteins are coded with the same negative character. We then introduce the proteins to beta-mercaptoethanol, which breaks any disulfide bonds and makes all the proteins have the same wet noodle shape. Then we place the proteins at the negative end of the electric field and watch them travel. With the proteins separated by pH and size, we can compare them to other known proteins in order to determine their precise size and charge.
Just a little SDS page, just the dab. Separate by size.
Gotta separate by size.
First we make a little gel,
Gonna guess it's made of agarose.
probably made of agarose.
Hey, 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 help it.
We make some alterations to our protein.
Gotta change that protein.
Treat it with SDS and beta-mercaptoethanol. Just a little SDS page,
Just a little bit, that stuff's expensive.
separate by size.
Large, medium, small.
Take away the charge and the shape,
Gonna take it away for good.
so we can separate by size.
Like we just said before.
Then we run it through an electric current. If it traveled far, it's small.
Bingo.
Just a little SDS page,
Not a whole lot, just a little.
separate by size.
Gotta get it. Large, medium, small.
We just wanted to see that size.
I just gotta know the protein size. Well, Kyle, did you learn something new today?
I did. I learned how to separate proteins based on charge and size at the same time. And that these taste pretty good.
Well, Kyle, I can definitely agree about the first part. You did learn something about that, but I don't know if those taste good. You should definitely probably put that down, not eat it again. Anyways, Kyle said it, guys. I'm glad you've learned how to separate proteins based on charge and size through two-dimensional gel electrophoresis. Now tune in next week for my segment on the beauty of proteins.
Yay!
Con los terroristas.
And do the Harlem Shake.